For single motor loads, the configuration where the conductor size is less than the overcurrent protection device rating is acceptable under specific circumstances. According to NEC 430.22, conductors must be sized for 150% of the motor full load amps, or floor, for short time duty motors rated at 30 to 60 minutes. NEC 430.52 dictates that overcurrent protection devices, specifically inverse time breakers, should be sized at 250% of the motor's FLA. The reason this disparity between conductor size and breaker rating is permissible is due to several factors. Firstly, motors possess inherent thermal overload protection. These motors are equipped with internal temperature sensors. These sensors are designed to trip the motor off before it overheats, preventing damage, even if the conductor size is smaller than the breaker rating. Secondly, inverse time breakers play a crucial role in this configuration. These breakers have a delay tripping characteristic. This means they are designed to take longer to trip at low overcurrents. This delay allows for brief motor starting currents, which are typically higher than the running current, to flow without causing the breaker to trip unnecessarily. Thirdly, the configuration, when adhering to these guidelines, meets the requirements outlined in both NEC 430.22 and 430.52. It is imperative to note that this configuration is only acceptable for single motor loads. The rules change when dealing with multi-motor loads. In the case of multi-motor loads, the conductors must be sized for the sum of the motor FLA of all the motors protected by the overcurrent device. The reason for this stricter requirement is that multiple motors starting simultaneously can draw high current. If the conductors are not adequately sized, these high currents could lead to overheating and potential damage. In summary, for single motor load operating under short time duty, you can size the conductors at 150% of the motor's FLA and use an inverse time breaker sized at 250% of the motor's FLA. The motor's inherent thermal protection and the inverse time breaker's delayed tripping characteristic allow for this seemingly disproportionate sizing. However, when dealing with multiple motors on the same circuit, the conductors must be sized to handle the combined FLA of all the motors to prevent overheating during simultaneous starts. Understanding these nuances is crucial for ensuring both safety and code compliance in motor control applications. The NEC provides specific guidelines to ensure the safe and reliable operation of electrical systems, and adhering to these guidelines is essential for preventing electrical hazards. Always consult the latest edition of the NEC and consult with a qualified electrician or electrical engineer when designing or installing electrical systems. Furthermore, it is important to consider the specific characteristics of the motor being used, such as its starting current, duty cycle, and ambient temperature. These factors can all affect the proper sizing of conductors and overcurrent protection devices. For example, a motor that is started frequently or operates in a high ambient temperature may require larger conductors and a higher rated overcurrent protection device. In addition to the NEC requirements, it is also important to follow the manufacturer's recommendations for the motor and overcurrent protection devices being used. The manufacturer's recommendations may provide additional guidance on the proper sizing and installation of these components. Furthermore, it is crucial to ensure that all electrical work is performed by qualified personnel who are familiar with the NEC and other applicable codes and standards. Improper electrical work can be dangerous and can lead to fires, shocks, and other hazards. By following these guidelines, you can ensure the safe and reliable operation of motor control systems. Remember to always prioritize safety and consult with qualified professionals when necessary. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations to ensure safety and prevent hazards. When dealing with motor loads, understanding specific sections like 430.22 and 430.52 is crucial. These sections address conductor sizing and overcurrent protection, respectively, taking into account the unique characteristics of motors. A motor's full load amps, or floor, is a key parameter in determining the appropriate conductor size. For short time duty motors, those rated for 30 to 60 minutes of operation. NEC 430.22 mandates that conductors be sized at 150% of the motor's FLA. This oversizing accounts for the motor's high current draw during startup and intermittent operation. Overcurrent protection, as covered in NEC 430.52, aims to protect the motor and conductors from excessive current that could lead to overheating and damage. Inverse time breakers, commonly used for motor protection, are often sized at 250% of the motor's FLA. This seemingly high percentage is due to the breaker's inverse time characteristic, which allows for short duration overloads such as those experienced during motor starting without tripping the breaker. The combination of conductor sized at 150% of FLA and breakers sized at 250% of FLA might appear contradictory, but it is a deliberate design to accommodate motor starting currents while providing adequate protection against sustained overloads. Motors inherently have some degree of thermal overload protection. This can be in the form of internal temperature sensors or other mechanisms that detect excessive heat and shut down the motor to prevent damage. These built-in protections work in conjunction with the overcurrent protection provided by the breaker. The inverse time characteristic of the breaker is essential for motor applications. Unlike instantaneous trip breakers, which trip immediately upon detecting an overcurrent, inverse time breakers have a time delay that decreases as the overcurrent increases. This allows the motor to stop without tripping the breaker, as the starting current is typically several times higher than the running current. Code compliance is paramount. Following the guidelines in NEC 430.22 and 430.52 ensures that the electrical installation meets safety standards and minimizes the risk of electrical hazards. However, it's crucial to recognize that these guidelines primarily apply to single motor loads. Multi-motor loads require a different approach. When multiple motors are connected to the same circuit, the conductor sizing must account for the combined FLA of all the motors. This is because the simultaneous starting of multiple motors can draw significantly higher currents than a single motor, potentially overloading the conductors if they are not adequately sized. Therefore, for multi-motor loads, a conductor should be sized to handle the sum of the FLA of all the motors connected to the circuit. It's also important to consider the starting characteristics of the motors. If the motors are started simultaneously, the conductor sizing must be based on the inrush current of all the motors. However, if the motors are started sequentially, the conductor sizing can be based on the FLA of the largest motor plus a percentage of the FLA of the other motors. In addition to conductor sizing, the overcurrent protection for multi-motor loads must also be carefully selected. The overcurrent protection device should be sized to protect the conductors from overloads and short circuits, while also allowing for the starting currents of the motors. This can be achieved by using inverse time breakers or other types of overcurrent protection devices that have a time delay characteristic. Furthermore, it is essential to consider the coordination of overcurrent protection devices in multi-motor systems. Coordination ensures that the overcurrent protection device closest to the fault will trip first, minimizing the impact on the rest of the system. This can be achieved by using selective coordination techniques, which involve selecting overcurrent protection devices with different time current characteristics. Overall, understanding the specific requirements for single and multi-motor loads is crucial for ensuring the safe and reliable operation of electrical systems. By following the guidelines in the NEC and considering the unique characteristics of motors, electrical engineers and electricians can design and install systems that minimize the risk of electrical hazards. Furthermore, regular maintenance and inspection of motor control systems are essential for identifying and addressing potential problems before they lead to failures or safety issues. This includes checking conductor connections, inspecting overcurrent protection devices, and verifying motor operating parameters. By implementing a comprehensive maintenance program, it is possible to extend the life of motor control systems and ensure their continued safe and reliable operation. In addition to the NEC, other codes and standards may also apply to motor control systems. These include standards from organizations such as the National Electrical Manufacturers Association, or NEMA, and the Institute of Electrical and Electronics Engineers, or IEE. These standards provide guidance on the design, testing, and performance of motor control equipment. When designing and installing motor control systems, it is important to consider all applicable codes and standards. This will help ensure that the system meets all safety requirements and performs as intended. Furthermore, it is essential to stay up to date on the latest changes to codes and standards. The NEC is updated every 3 years, and other codes and standards may also be revised periodically. By staying informed about the latest requirements, electrical engineers and electricians can ensure that their work is always compliant with the latest regulations. In conclusion, the proper sizing of conductors and overcurrent protection devices for motor loads is a critical aspect of electrical safety. By understanding the requirements of the NEC and other applicable codes and standards, and by considering the unique characteristics of motors, it is possible to design and install systems that minimize the risk of electrical hazards and ensure the safe and reliable operation of motor control equipment. Remember that for single motor applications under NEC 430.22, the conductors are sized at 150% of FLA, and per NEC 430.52, the overcurrent protection is at 250% of FLA using an inverse time breaker. Firstly, inverse time breakers allow brief motor starting currents to flow without tripping the breaker because of their delayed trip time. Secondly, motors have inherent thermal overload protection, as well as internal temperature sensors that will trip the motor off before overheating. This configuration is only suitable for single motor loads. And lastly, multi-motor loads must have the conductors sized for the sum of the motor FLA of all motors being protected by the overcurrent device. This is because the starting of multiple motors simultaneously draws higher currents and could overheat conductors if not properly sized. Always consult a qualified professional for electrical work and comply with local codes. The goal is to ensure a safe and code-compliant installation, so adhere to the standards and best practices discussed.